So, if we look at your homework, all right, and the opening, which go together, we should be able to answer these based on our discussion of equilibrium yesterday. So, what two factors affect the rate of evaporation? All right, temperature and surface area. So, if we increase temperature, what happens to evaporation? It increases. If we increase the surface area, what happens to it? It increases. Okay. So, if you spread water out on a tennis court, the water will evaporate or dry faster. That's why we generally will spread water out before a tennis game. Okay? Now, I'm sure none of you have seen that because, as you explained to me yesterday, nobody plays tennis anymore. But that is one way to drive the courts faster before a tennis match. All right? What one factor affects the rate of condensation?
Concentration.
Concentration. What is concentration?
The amount of, I don't know.
It's just a number of particles.
Oh, okay.
Okay, just a number of particles. Now, what happens to the evaporation and the amount of the water, all right, in a liquid vapor system when the temperature is raised? Okay, the amount of water will go down. All right, so what happens to the evaporation? It increases. Okay, so evaporation will increase, the amount of water goes down. All right, so if temperatures decrease, what happens to the amount of water and the amount of vapor? So if we decrease the temperature, what happens to the amount of water? Will we get more water or less water if we lower the temperature? You'll have more water, so water is going to increase. What happens to your amount of vapor? You'll have less vapor. Now, before anybody can forget, all right, check to make sure you've clearly marked all of your openings so that I don't miscount them. Make sure you put your names on them. Okay, unlike the Deja who forgot her name on her quiz yesterday. All right.
Yeah.
Yes, I'll hand it back in just a second. So make sure you put your names on your openings. Make sure they're clearly marked. So that'll be great for the second period, and I can't go. Did you only have 9? So that I don't have to try to figure that out myself. And then stick them on the stool up front. Okay? And then I'll hand back to quiz papers.
That is a chair.
Okay, put it on the chair. I've been duly corrected. Well, it used to sit over there in front of the lectern when it was taller before I got a new smartboard. And it worked beautifully. It doesn't work now because it's shorter.
Oh.
Yeah, I'm just going to start marking these charges so I don't have to keep fixing it in the attendance.
Why were you on the phone?
Oh, you are a deal?
I was watching the home like, I don't think some slides, yeah, just say no.
Good luck.
So I guess I'll do it.
It should be good all day. We'll be fine.
They stop saying it like that.
She's gonna still alive.
Yeah. Yep.
You only get up when you need to.
She's solid.
Watch your sidewalks. Rough.
Yeah, but what time she needs to turn this
And don't walk like that.
Wait.
Huh?
On the back. Oh, I didn't.
Put your homework in my stack up there while.
So I was gonna say, I forgot to get that.
In the stack, I'll take care of it.
Oh, yeah.
I really thought it.
Did you do it?
That's not good.
I think
This one just says show you the rules.
That one and the graph.
So I
Bro, it's hard to do big.
I thought it was gonna be like, don't look at it, sailor.
The way you're walking right now.
It's not, it don't hurt right now, but I try to go in the hallway and listen to my next class.
Which box? Just don't pick your feet up, just.
Oh, right there with the
slide.
opening back. Stick it in the back.
Yes, like when she's walking, the.
You better not be lying. Cause I just seen.
Good luck. Mine's number 9 wrong.
I don't know, I'll look at it in a second. All right, did I get all the openings that I'm getting?
Yeah.
Put it on my desk for you guys. All right, let me send Devontae out now that I think he's gonna remember this in 2 weeks, but. You too. You gone with it.
But the same thing, I did for number 6, I did for number 9, and they were the same.
Right here, this one? Yeah, right there's fine. Let me get the paper, so, I can use the bottle. What am I looking at? Number which one? 9.
Oh, no,
All right, so number 9 says that we have the heat of vaporization is. All right, they're telling you that heat of vaporization is 1140. Oops, 11. I should write the number down right. They're telling you the heat of vaporization of a liquid is 1340. Okay. Then they say, what is the minimum joules of heat? Okay. They're asking you for heat. And I've given you mass is 40 grams. So we're looking for Q. So Q equals MHV. So you're going to say Q equals 40 times 13. 40. And calculate. And you get 5360. Or 53,600. What else?
1.
Which one?
1.
All right, see how it says they're arranged in a regular geometric pattern?
Mhm.
Is a solid, liquid, or gas a regular geometric pattern?
A solid, but.
So which one of those has a solid?
D.
That's why it's D.
No, I picked salt because I thought it was a geometric pattern.
It is, but what does it say beside salt?
AQ.
It's dissolved in water. So that would be like you were sent home by the dentist or the doctor and they told you to swish some salt water.
Number 9.
Can you do 8?
Yeah. Number 8 says which type of change can reach equilibrium. That was the last thing we did on Wednesday. And we said chemical equilibrium can be both a physical or chemical change in the definition.
Did they really
It's
postpone the talent show?
Is it because all that probably happened?
Probably. Because there will be outside visitors in the building and they want to return the building to some normalcy before we do it.
Why? Because they have cop cars though.
Hmm.
Just because there's cop cars.
Well, there are cop cars outside just because of the rumors and things that are going on in the community, just to make sure everything's safe and people feel safe.
Oh, that's just wonderful.
I mean, there was never a weapon on campus. There was never any reason for concern, but because students feel unsafe, parents feel unsafe, you've got to make people feel safe. So we have extra security on campus today. Well, she's got to look out for everybody.
It's crazy. They just so
I came in with
I'm so sorry.
Also?
It's okay over there, Almaj. It's your day. Are you 17 today?
No, she's 12.
She's 12.
You know,
She's a child prodigy.
Why are we gonna call y'all again?
I don't believe so, but we're supposed to limit access to the hallway.
So is the show not today?
It's not today. It's been postponed.
She thought.
Oh, no. My sister told me, but I wasn't sure
It's been postponed.
to when. I'm so happy.
They said shortly after we came back from break, but I don't know how shortly
I
after.
think she said it's that
Probably
Friday.
February.
Everybody need their $2 back.
Right.
No, they say they're not canceling it. They say they're still doing it.
You know
So,
what happens if they do end up canceling it? I'm getting it.
no, I'm assuming they're still doing it.
Oh my God. I don't try one problem. You only get a $5 discount.
They just had like a little.
So, all right. So we're done with the quiz. Okay, let Devontae and Annette back in before I forget them. All right, let's move on and talk about homework real quick, and then let's at least get through boiling and phase diagrams today. If I don't get to start kinetics, I will not be completely heartbroken. But we have to get through boiling and phase diagrams today.
So boiling is just pretty much take all day.
Boiling and phase diagrams can take a good part of the day.
And then we'll learn how to
Now, if you won't leave that cracked, because I don't know, I would imagine the gentleman will be by for recycling, but I don't know. All right, so we talk about our homework real quick. The only thing we didn't do was the very last questions. Let's run through those 4 answers quickly. Because you will see this on a quiz when we come back. It will not be Wednesday. It'll either be Thursday or Friday. We come back on a Wednesday. It's your birthday. The 2nd. Okay.
I think it is.
Okay. I'm like, I thought you didn't know when day your birthday was. Oh, okay. It's a Wednesday. It's a Wednesday. It's a Wednesday. All right, there's the questions. So we did 33 yesterday. So 34. When you look at number 34, it's telling you decide what temperature you would need to get these things to happen. So do we need to increase the temperature or decrease the temperature if you want these things to happen? So if you want to increase the rate of evaporation, what would you do to temperature? You would increase it or raise it. Okay. So if you want to increase your concentration of vapor, you want more vapor, what would you do to the temperature? You would what? You would increase. So if you want more vapor, how do you get more vapor up here? Do you need more evaporation or less evaporation? You need more evaporation, right? So you need more evaporation to get more vapor. So in order to get more vapor, you have to increase your temperature. All right. If you need an increased rate of condensation, what do you have to do to get more condensation? You need to increase temperature. Why do you increase temperature? What do you need to get more condensation? You need more vapor. Okay. You need more of this to get more condensation. Okay. So to get more condensation, you need more vapor. So you have to increase the temperature. So the last question says you want more liquid. What do you do to get more liquid? You would lower the temperature or decrease the temperature. So the only thing that's going to lower the temperature or decrease the temperature is to get more liquid. Why are y'all laughing?
Because this class is just so fun.
I'm sure. Raising and lowering the temperature is hilarious. All right.
I guess so.
Whatever. Did you get them right or did you get them wrong?
I guess. I just wrote something down because I thought you were going to give us a grade for it.
You really thought I was going to check homework for 4 questions?
Yeah. I really just wrote something down. I got it right. At least I tried.
Wait, so it's increase.
No, it's increase, 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 decrease. All right, we did that. Where are we at? Done, not done that. Done that. I know you did.
Can't we just take a break?
Nope. Can't. I don't care. Write it down and you can study it after break for all I care. All right. You will see this stuff on the exam. It is what it is.
Don't you scare
Now, everybody knows that boiling will allow a liquid to change to a gas. However, something else has to happen besides just a liquid changing to a gas, because this also is evaporation. So there has to be some other special characteristic that goes on that makes it unique. All right? A liquid changes to a gas when the equilibrium vapor pressure equals the atmospheric pressure. Now, the part that I wrote in green is the piece that most people don't know when they take any science class. The part that I wrote in black is the part that everybody just assumes because they've learned that in other science classes. All right? Everybody knows that the liquid changes to a gas, but that's the evaporation part. In order to boil, liquids do not all boil at the same temperature. Okay? When we talk about a boiling point, when we talk about the boiling point of water, most of you would tell me the boiling point of water is 100 degrees Celsius. That number is an average. It's not an absolute. It changes with location. Okay?
Explain this.
You're going to.
Is that like when you like you're at like a certain elevation?
Yes. Exactly. All right. Now, Jada just said, is that like when you're at a certain elevation? The answer is yes. Because what in that definition is going to cause the boiling point to change? The atmospheric pressure. Now, most of you probably don't watch the weather. Right? Back before the snow hit, I told you I would not see you Monday and Tuesday. I doubted I'd see you Monday through Wednesday. I said if we were lucky, I wouldn't see you all week. I really didn't think it would be all week. Okay? I like to watch the weather. All right? Not a weather forecaster by any stretch, but I do like to watch the weather. So,
Is it true that really is like a black screen?
say what now?
Is it true they're looking at a black screen?
Yes.
Walking around?
Yes, they're just walking around in front of a green screen.
And there's a TV with the real stuff on it, though, that they're looking at themselves.
Yes.
And they
That's why they're
read,
never looking at the camera.
they like read lines.
That's
Yeah.
why they can't wear green clothes.
Yeah, they blend in.
Are y'all
Now.
serious?
But my point is, when you look at the weather, they always give you what? Atmospheric pressure. It changes. When you took earth science, did you talk about high pressure and low pressure? Okay. Now, you don't have to not remember a whole lot about high pressure and low pressure, but hopefully you remember just a tiny, tiny bit. All right. Do you remember anything about high pressure and low pressure? For example, today, would we be under high pressure or low pressure? Low, because it's doing what? It's raining. When it's nice and sunny outside, we're under what? High pressure. As long as you remember that, we're good for the day. That'll work for what we needed. I was hoping that's what you'd remember. Okay? And it's okay. There's a lot more to it than that, but for what we need for right now, I can live with that. Now, for the most part, if it's nice and sunny outside, you're generally under high pressure. Rainy, snowy crap, you're under low pressure. All right? Now, What?
Look,
I'm not going through that right now.
but I kinda need, I'm not gonna remember. I always forget it.
It's okay. It'll be all right for today. We just need to talk about it with bullet
No,
points.
you just told me I needed to remember it for today.
We only need to know high and low pressure for today and how it affects bullet point. Okay? So, it affects boiling point. All right? Now, if the pressure increases, it's going to affect our boiling point. If the atmospheric pressure is lower, it's going to affect our boiling point. How? Now, you got to work with me on my tacky pictures.
Are you drawing the boxes?
No. I can draw a box.
But do we have to draw?
It's a pot.
It comes with an explanation, so I would recommend
Your
it.
handle is too small. That's a measuring cup. That is a pot.
That's an electron stuff.
That's
That
a
is
pot.
disgusting.
I told you it was a bad picture. I gave you that up front. So do you have to be that critical?
Yes, I have some.
I think it would make it better if you made it a square block. I've never seen a circular.
It's really not that bad, honestly. You don't want to fix it. You don't want it.
This is design.
You know what?
Everybody's a critic these days.
I'm an artist.
There you go.
Yo, that just looks horrible.
It looked like it.
It's fused to the stove because they wanted a square bottom. Now, we put it on the stove. All right?
Huh? Oh, I can cook.
We're going to talk about what happens in the pot, so I would recommend it.
This is not art.
I tried to say that up front, but now y'all are all critical. All right? As the water heats, kinetic energy increases. The water breaks the surface. And evaporates. Now, when the water evaporates out of the pot, does it just evaporate? And we just lose our water? No. Okay. It hits cold air up here, right?
Yeah.
Now, what happens when it encounters that cold air? Cools down. And what happens when that warm air that just, or warm water that just evaporated, it became vapor, hits that cold air? Well, it is steam when it went up, right? It evaporated into steam. So what happens when that steam hits that cold air? It condenses. It becomes water again, right? All right. So steam or the vapor hits cold air and condenses. Now, you can do this very easily. If you don't believe me, put your hand over the pot. Don't put your hand in the water. I didn't say that. All right, but put your hand over the pot and your hand will feel what? Wet. All right, if you put your hand on the stove over here, not on the burner, it will also feel wet. Okay, do not touch the burner. Do not put your hand in the water. I did not say either of those two things. Okay, go ahead and do that. Don't tell anybody I told you to do that. Okay? Now, this right here, okay? I'm going to point to it and I'm going to give it a name. It's called equilibrium vapor pressure. I'll let you write it down before I open my colors back up. Okay?
Wait.
I'm just going to write something right here. The pressure above the pot is called equilibrium vapor pressure. I'll stop there for a minute while you're catching up.
Didn't you miss right there?
They're out caroling, I'm pretty sure.
Like outside the school?
No, like in the building somewhere.
Oh.
That was the plan last I knew.
Okay.
Are they coming to our class?
I don't know. Given our hallway is so short, I don't know. I hope they're coming, but I don't know.
I thought we
Isn't
were
that
supposed to eliminate.
Yeah, I just got here.
Okay.
Somebody get man.
Of course you
They
did.
were just in there though, I heard them singing.
Yeah.
I assume they were practicing to go out to carol.
Not here anymore.
Oh.
My dad. Yeah, I heard them singing that face.
Good.
I think that was
All right, are we caught up?
No.
Now, because we've said that this is called the equilibrium vapor pressure, I sort of think this is understood, but let me be clear. What two things are going to be in equilibrium here? Okay, so this is equilibrium between the liquid and the vapor, and that means that evaporation and condensation are occurring at equal rates above the pot. Okay? I just want to make sure everybody understands that. That's a continuation of yesterday.
That's condensation, right?
Yep. COND is condensation.
No, they look like it.
Okay. I know my handwriting's not too good.
I was about to say Miss McAllister.
It's so sad. I don't even know who that is.
She was just weird.
Who is Miss McAllister?
She was my teacher. She was there for like, I mean, so
you're
like,
She got mad at 80% like one goldfish.
Huh?
She got mad at 80% like one
I think it was Brooke.
No, it was Katie.
Oh, Brooke stole one too.
She really flipped out.
That was a whole big thing.
Right, she had the big box of goldfish. She got
No,
mad.
she thought it was good.
Oh, y'all meant like the crackers.
Yeah.
Yeah.
I thought you meant like a live goldfish.
She took her, she
What?
took one goldfish out of this big goldfish container.
Sir. What happened?
George's also.
It's because of the draft, because they opened the main door.
Oh, no.
First of all, it didn't open and it closed.
My door would close by itself sometimes. It scares me.
Yeah, I'm just gonna close.
It's okay. Go ahead.
Yeah.
All right.
That's pretty.
It's like the air.
So, if we're going to boil water,
It's been open and closing, and that's.
the stove eye continues to do what to the water? Continues to make the water heat. So, as temperature increases, what happens to the equilibrium vapor pressure here? What happens to the pressure above the pot? Does the pressure increase or does it stay the same? What happens to the evaporation? Does the evaporation increase or stay the same? Okay, so as temperature increases, the evaporation increases. So equilibrium vapor pressure increases. Okay, are you with me on that? So as temperature increases, evaporation is going to increase, so the pressure above the pot is going to increase. When are we actually going to boil? Because all we're doing so far is evaporating water out of this pot that's going to keep recondensing. When are we actually going to see the bubbles?
Does it have to do with all of this too much?
I'm sorry, we're not boiling yet. Well, think about the definition. When are we actually going to see the bubbles? That's right, when we reach atmospheric pressure. Okay?
This is confusing.
All right?
I didn't think boiling had anything to do with what was happening up above it.
It does.
Why?
The water will boil when the pressure above the pot, which is called equilibrium vapor pressure, equals atmospheric pressure. Uh-huh.
Are you gonna tell us how that affects boiling?
Yeah.
That makes no sense to me.
Are we done with what? No. I'm done with what I'm gonna write right there, but we're not done with it, no.
That says a graph. We're making a graph.
You're gonna learn how to read a graph. Two different kinds of graphs today. They're both pretty easy though. Both of the graphs we're doing today are easy. They're not hard.
You always say that, you know it's great.
Was the phase change graph hard?
Love it.
No.
These two are hard either.
I'm sorry, I don't have to miss.
We're gonna have to miss what? I don't care if we miss fourth period. I'm praying my class misses fourth period. One told me he was going out the side door. I'm still praying he's doing it.
My mom, she brought me back to school the other day to pick up my car after my appointment, and someone who was leaving school, like skipping, they were running across the road and they fell and they flipped.
Why it was never that serious?
I feel like a prison break.
I don't know. Do it. Feels good.
All right, does everybody have what they need? So we can go back and explain for those people who are like, am I going back to explain? Yes? Are we done right? All right, so when you put water on the pot in the house, at some point over the break, let's say you want to make some spaghetti noodles, okay? With some rice, something. You got to boil some water, all right? For whatever the reason, you're boiling water. When you put it on the stove, does it boil instantly?
Yes.
I need your stove. Okay? So, when you put water on the stove, you turn the eye on. It starts to get warm. It does not boil instantly.
The eye of the stove.
The eye of the stove gets warm. It heats the bottom of the pot.
Is it eye?
They're called eyes.
Like
eyeball.
Like EYE.
Oh, I thought the eyebrow like.
I don't know why they call them an eye. They're 4 eyes. Large eyes, small eyes.
I have never heard that.
Me neither.
That's what they're called.
Wow. I thought they were called burners.
Yeah.
They are, but they're also called eyes. I don't know why, they just are. Now, so the heat is transferred to your metal pot. The metal pot transfers the heat to the water, right?
Yep.
Now, as the water molecules move faster, Annette, those water molecules that are at the surface of the water, okay? And we're going, who?
That
nails.
Right. Okay, Molly, we get it. You got your nails done.
No, I didn't. Oh, what was I? It was. Right, when you get your nails done, I'm sorry.
You're breaking my flow here.
Where they go and get brown paper? What is that?
Right now. I was talking about that day.
That's the triple step.
Are you okay over there?
Oh, yeah.
I'm good. Did you have a rough day?
Yeah.
Okay.
You just sitting there.
I shut up.
Oh, you gotta hate when that happens. Particularly the day before break. Because you just stay home.
I was really hoping I'd
Oh.
Wait, I did.
That's better than Port Louise yesterday. Whoa, stop.
I didn't know that we were on yellow or not.
You did keep your recording.
But
Although I can live off the expression on his face for days. When they escorted him in here. Now, so when you put the pot on the stove and the liquid starts to get warm, where do the particles escape from when you evaporate?
I don't know.
The evaporation takes place at the surface. Here, we're gonna make a list. All right?
I didn't get my room.
Yeah, I know, you don't do anything.
No, she turned 13. Said, "You're a teenager now. You think you're grown."
She's 12.
All right, when particles escape the surface of a liquid, okay? Evaporation takes place at the surface. Boiling can leave the bottom of the liquid, okay? Particles cannot evaporate from the bottom. They can only evaporate from the top, which is why when we talked about yesterday, what are the two factors that affect the rate of evaporation? Temperature and surface area. So if we want things to evaporate faster, we have to do what?
Increase
the surface area. We want to spread it out because the particles can only leave from the where? Surface, from the top. So if you have a lot of water and it's deep, is it going to evaporate quickly? No. You need to spread it out. The particles only leave from the top. Okay? Does that make sense? Some? Okay, at least it's something.
So that's why it takes so long to microwave food. If it's a lot, stack.
If it's stacked deep, yes. Now, when you think about the water on the stove, the particles escape from the top of the liquid. Now, you need those particles at the top, all right? They evaporate. They're up here. They hit the cold air. What happens to them when they hit the cold air? They condense. Now, evaporate, condense. Evaporate, condense. It creates a what? A pressure. Okay? Can you hang? You don't even have to call it by the right word. When they evaporate and they condense, they create a pressure. Okay? It's coming back down. So they're evaporating and condensing, and they're creating a pressure above the pot. You can think of it that way. Yes. 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 It's a type of heat transfer. Yes. Convection is a type of heat transfer. That's why some of you moan about it being cold in here, because drafts are convection currents. Yes. A draft is a type of convection current. Yes. All right. So we're creating pressure above the pot. Now, put the pressure above this pot has to equal the pressure in the room. Now, can everybody agree or understand that there's pressure in the room exerted by the atmosphere? Yes. The atmosphere puts pressure on our lungs. Some days there's less pressure based on it's sunny outside. Some days there's more pressure because there's rain outside. Huh? It's actually less pressure. It's low pressure. more pressure when it's high pressure.
But if you're in the mountains, sometimes.
We're gonna get to that. Hold that thought. We're going there next. Wait. We're going there next.
Hold that thought.
All right. I'm bringing it back. Just hold that thought. It's part of our discussion next. All right, we're getting there. All right, so as the pressure builds, okay, above the pot, you still won't get bubbles. You still won't boil until this pressure above the pot equals what? The pressure where? In the room. You have to equal the pressure in the room, the atmospheric pressure. Once you equal whatever the atmospheric pressure is, then you get those big bubbles and you boil. Okay? Whatever the atmospheric pressure is. Today it's rainy, so it's lower pressure. It will boil a little faster. Now, supposedly tomorrow it's going to be sunny. We'll have high pressure, so the pressure is higher. The boiling point will be slightly more because the atmospheric pressure will be slightly greater. Okay? Higher pressure takes a little more effort to boil. Now, to go to, I'm coming back to this. Leave me a little bit of space. You need 3 or 4 lines. Now,
That is a horrible name.
Hey, I was trying to get
Yeah.
She officially lost
I thought she was drunk.
What does Piedmont even mean? Like, that's the dumbest word. I don't see it.
I didn't make it up.
No, but like, I don't understand.
That is something I was.
We have some hills.
That's the mountain.
What's the mountains?
Why is your toes slanted?
Because we're at lower elevation. That's based on elevation.
You know what? I'm gonna let you have it. I'll let you have it.
Thank you. We're at lower elevation at the coast. We're at sea level.
You're welcome.
We're somewhere around 800 feet above sea level. Mountains are around 2,500 feet above sea level. Now, how does air pressure in those 3 spots affect boiling? What can you tell me about atmospheric pressure in these 3 spots?
They're
different.
It's higher.
Okay, tell me about atmospheric pressure in the mountains.
No, that's not.
lower.
It's lower.
It's lower. Okay.
Oh,
Okay, that's what.
Oh,
This one decreases when you
I mean, well,
increase out.
okay.
Okay, that's like the same thing when you're on an airplane.
Bro, I'm telling you.
Like I couldn't hear under.
Oh, that was too early.
Okay, so explain this. As you
Okay, we're gonna get there. Hang on. All right, so at the coast we have what?
High pressure.
All right, we have high pressure. All right, so in the mountains we have low atmospheric pressure. At the coast we have high atmospheric pressure. So how does that affect the boiling point?
Boiling point is lower.
That's right. All right. So in the mountains, we have a lower boiling point. So at the coast, we have a what?
High.
We have a higher boiling point. Now, how does that affect cooking rates?
The coast is lower.
So this takes less time to boil.
It takes less time to boil where?
At the coast.
The mountains.
Mountains.
It's going to take less time to boil.
Hold
on.
That's
Okay,
how
I
they
realize.
tell you.
Okay. Boxes and stuff. For higher altitudes.
I've never seen, they really did that?
Yeah.
Okay. All right.
I prefer.
Yeah, me too.
Except for the blackberries, that's not.
All right. So in the mountains, you have to cook it longer. All right. Why do you have to cook it longer in the mountains? All right. In the mountains, you're going to have to cook it longer because it's going to cook at a lower temperature. Okay. It cooks at a lower, we're using boiling point. Okay. But you're going to actually wind up cooking it at a lower temperature. So you have to cook it longer. Okay. at the coast, it's going to cook at a higher temperature. So it's going to cook what? It's going to cook faster. Okay? Have you ever gone home and you want something to cook in the oven or on the stove and you just cook it at a higher temperature that it says to cook it at? And Karina's nodding, yes, I have. I've gotten so at home I need to cook chicken at 350. Shelby's got dance. I don't have time to cook it at 350. I push it up to 375 or 400. Okay? I just need it to cook faster than the 350 it calls for. Okay? I don't have an hour. I need 45 minutes. I just cook it at a higher temperature. Okay? Huh?
What?
No, I just need the chicken to cook faster.
No. You're not supposed to do that. Are you taking food? Yes, I'm taking food. You're not supposed to do that.
Do what?
Oh, well, I just don't have an hour.
I had this problem. She told us we're not supposed to. She yelled at us when I was.
Oh, I'm not supposed to do that?
She told us we're not supposed to do that.
I mean, you're gonna die anyway.
Oh, I'm not doing that.
It's done every time I do it. I just don't have an hour, so I need 45 minutes. I just give it.
Little things crawling inside.
I just give it 375 instead of 350. Okay?
So you just have to make sure moms work hard.
Alright.
Like, you
Yeah,
can't breathe.
short
or
do not.
pressure in the lungs. So
A lot of athletes will go train in the mountains because it works your heart.
yeah, that's what I'm saying. If you can't breathe, if you get higher up in the mountain, there's a lower pressure.
It's more about the fact that they're just not used to that pressure, so it requires their bodies to adapt to it. You can, you just have to get used to it. It's thinner air. But you can. A lot of athletes will go train in the mountains because of the air quality up there. It's a great environment to train in. And then when they come back down, because they're used to that thinner air and that air pressure, it's easier for them at a higher pressure. They're more equipped for it. All right, questions. Do you think you have it or no? No, you
If
can't
I
stop.
say yes, should we stop writing notes?
No, we're not stopping. All right.
It's only like 3 minutes to my date.
All right. The equilibrium vapor pressure graph is on the back side of your homework from last night. Now, reading the graph is just like being able to read any other normal graph. But there's one thing on the graph that I have to talk about that goes with phase diagrams that I told you we have to do today because we're getting through that part today, even if you have the attention span of a squirrel. So, we have to be able to find normal boiling point on this graph. All right, now, if you're Lolly and you Googled it because you were just that good yesterday, then you know how to do this. All right, normal boiling point is the boiling point or the temperature at standard pressure. Okay? It's your temperature at standard pressure. I just wrote it on the board. It's the temperature at standard pressure. So, at standard pressure. So, the pressures can vary. So, you have to look at the graph. So, if the graph says atmospheres, you would look up what along the side? 1. But let's say that it says KPA. Okay, so what would standard pressure be on KPA? 101.3. Okay, we'll just use 101 because we're not going to be using decimals on a graph. Okay, so if it's 101, you would have to take and draw a line across and find the intersection of the 101 on your graph. Now, from there, you would just have to read down to find temperature to know your normal boiling point, okay? But in order to find the normal boiling point, you have to find the temperature at standard pressure. Now, standard pressure, we have essentially 4. PA is generally not used on graphs because PA is the one that's times 10 to the 5th. They generally don't use times 10 to the 5th on the graphs, okay? But you can see atmospheres, millimeters, torr, or PA. Any questions about that? You still got your homework from last night?
Not for last.
Night before last. All right, with that graph, pull that out real quick. Let's run through and do a couple of those to make sure everybody's good on that graph, and then we'll finish up with phase diagrams. And if we get through phase diagrams, I'll even stop and not do kinetics today.
Wait, we're not on phase diagrams yet.
No, we're on equilibrium vapor pressure.
Are we done with equilibrium?
We're on 3.
Are we done?
Alright.
We got to get through 4. I won't do 5, but we got to get through
How
4.
long is 4?
We have to draw it, talk about its parts, and practice it. It will probably take the rest of the period of rate removal.
And that's why you said we won't even get it. Okay, try to say.
But if we go quickly, I'm willing to stop. If we go quickly.
Yes.
Homework from 2 nights ago, the graph that I said don't lose.
Basically, the temperature one.
That one right there.
Oh,
There you go, backside. We're gonna try to answer the questions.
oh, I already.
You already did it?
Yeah.
We'll pull it out.
Actually,
The ones I want to do are 7, 8, and 9. And 10. Really 7 to 10 are the ones I want to do. 1 through 6 should be easy, but you're estimating. I'd like to do all of them, but
okay, we can.
Oh, wait.
I like how that did. Yeah. It was so oh, what did you say?
I was that's weird.
Oh my God, that was him.
I don't know if it was he or so.
Were you the kid that kid passed out?
No, that's.
Oh my God,
David leaned on him.
are we doing the practice or not?
Just,
What?
Are we doing the practice or not?
yeah.
Find the answers.
Are we waiting on you?
No, you're doing it. I know the answers.
Right in front of me.
He was just like,
I was looking at Trey and Alice.
Well, I'm Mark. Who came in? Jada came in and
I
what?
was like, I couldn't even see this. Wait, they were embarrassing.
oh, it was hilarious.
It was funny. And like, oh,
Amaj, did you do all of them on the backside?
All of them.
And you knew how to do normal boiling point?
I mean, I tried.
Go back and fix them now that you know how to do them.
I don't even.
Find standard pressure, draw a line across the graph, and fix them because you probably did them wrong if you didn't know what it was when you did it the first time.
Oh. That's weird.
And Lolly and Jada, we took up openings today also. Okay, and that would just be Lolly, that applies to them.
Wait, is today's open or different?
Huh?
No, today was the 10th one.
That was 10th.
We do 10. Which ones do we do?
Yes.
7.
What?
I want you to do all 1 through 10, but 7 through 10 are the most important.
So we do 7.
Yes.
Yes. Oh my God.
Bye.
We wish you a Merry Christmas. We wish you a Merry Christmas. We wish you a Merry Christmas and a Happy New Year. Good tidings we bring to you and your kin. Good tidings for Christmas and a Happy New Year. We wish you a Merry Christmas. We wish you a Merry Christmas. We wish you a Happy New Year. We wish you a Merry Christmas.
How you say that?
We'll be right back.
Make another one.
No! Now we really not gonna pick.
Make another one.
It's my birthday.
Now, we do numbers 7 through 10. Look, squirrel. Wait. One, you're gonna find standard pressure. So, that's 4. So, what's that? 760?
It's 760.
You're gonna find standard pressure between 700 and 800, so estimate 760, draw it across. It's in 4. Alright, so for those of you who are, like my girls over there going, why has it gotta be 760? Alright, what is your pressure unit right here? It's torr, right? So what's standard pressure on torr? So 760. And draw a line across here. All right, so for A, you're going to read down. I'm trying to estimate with a straight line. It's not working too well. It is sort of crooked. All right, find the temperature. Then for B, try to draw a straighter line than mine. And then C, but you got to draw in a line at standard pressure first. Okay, so I put in 760. Does that make sense?
Yeah.
Okay. But that's how you do normal boiling point. You have to draw on a line at standard pressure.
So if our answer is like a little bit different, that's okay.
Yes, they're going to vary. I'm going to give you a range of temperatures for an answer. Yes. We're getting ready to talk about that. That's why I said 7 to 10.
Is it A?
Maybe.
It's either A, B, or C.
That's very good. All right. So if any of you did number 1, all right, what's the temperature for 400? If you read across here and estimated, what'd you come up with?
39.
Somewhere around, I hear 39. I heard what else?
38.
38. I had 36. So somewhere in the upper 30s. All right. For liquid B, 70. Anybody else? So somewhere around 70. If you're a little above, a little below, that's fine. Number 3, 198, somewhere in that range. All right. Number 4 through 6 is going to have a lot more play because these are bigger numbers. All right. What'd you get for number 4? 350. What'd you say, Jadasia? 390. 400. So somewhere between 350 and 400. You take 35, which is estimated here, and up to A, and then read over. All right. So B, somewhere around what? I got 175, 150. Okay. I had 180. 200. Okay. So somewhere between 150 and 200. All right. Number 6. I hear 50. That's what I had. 50. All right. Number 7. What have you got for 7? Those are the ones I've drawn on the board, although my line's a little crooked. 52, 54, 55. Okay. I'd tell you 60 is a little high, but I just would. I'd go somewhere between 52 and 55 myself. Your line's even more jacked up than mine is with 60. All right. 8. 83, 82, 85. I would have said 85 is on the high end. All right. You up there with Caroline. All right. And number 9. 110. 108. All right. And number 10. Which one has the highest intermolecular forces? C. The reason. Highest boiling point equals strongest force. Okay? The highest boiling point has the greatest force. Questions? The intermolecular force is hydrogen bonding, dipole, and LDF.
Are we done?
Nope. Now we got to do phase diagrams.
Yay.
Yay.
Oh.
Yeah.
Take like 5 minutes.
All right. Phase diagrams are easy. That's not what I meant to do. All right, phase diagrams show where solids, liquids, and gases exist using a graph. Okay? They show where solids, liquids, and gases exist using a graph. So, I do not recommend you draw it really teeny tiny because I'm going to label multiple things on this graph. That or you're just going to need to draw more than once. It's not hard to draw more than once either. Temperature is always on X. Pressure is on Y. This graph is always drawn in a Y shape. Okay? It will always look like a Y. It does not necessarily have to look identical to this Y because the Y will shift some this way or this way, but it will always be a Y shape. Okay? Here is always going to be a solid. This will always be the liquid in the middle of the Y, and the gas or vapor will always be down below. Okay? Everybody with me on that? Okay. Now. No. We got 1, 2, 3 points to learn. Now, the lines equal equilibrium. Okay? Now, they're not all the same equilibrium, but they are equilibrium. So, think about what you know. If this is a solid and that's a liquid, what equilibrium is this line? If this is a solid and that's a liquid, what equilibrium takes place across this line? What? Melting. And what else?
Freezing.
And freezing. Okay? So what takes place on this line? Right here. Evaporation and condensation. And what happens here? Sublimation and deposition. Okay? Questions about that? Huh? Yeah, I had 2 chocolate chip cookies and a bowl of ice cream last night. Somebody told me it was Christmas. You know, I had lost 32 pounds. I'm back down to 29.
It's Christmas.
Yeah. I'll remember that in January when I'm starving. Thanks. Just leave it on. Huh? I don't care what kind you got.
I wasn't thinking that.
2 more dozen.
You should bring some here.
No. For later?
No.
Yes, she does. She just did it.
No. I have to have some self-control. No.
Sorry to disrupt.
You're fine. All right.
Wait,
You need me to go back?
You're too tall.
What you doing?
No, you're not. No. You own any heels?
Got it? All right. So the first point we're going to do is the easiest. It's called the triple point. It's the point, the solid, the liquid, and the gas all exist at equilibrium. Yep. Okay? The point, the solid, liquid, and gas all exist at equilibrium. So, to find these, it's at the Y intersection. Okay? It's at the Y intersection. It's not hard.
And then you can just, you like have all of this information where you don't look at everything.
Right, I really don't understand.
All here.
All right, so and I'm going to use this one because my other one's pretty cluttered. All right, so if this is my Y graph, where is my Y intersection? Right here where the point is like this, right? Yep. I wasn't really expecting one that made sense. It was a dumb question.
She said, where is the intersection?
So I said it was a dumb question. All right, so that would be my triple point.
Yes, there is.
Now, if I wanted the triple point temperature, you would have to read down to where? Down to the what axis? X. And if you wanted the triple point pressure, you would read across to the Y. Everybody okay with that? I said if I asked for the triple point temperature, you would read down to the what? X. And if I wanted the triple point pressure, you would read across to the Y. Everybody okay with that? Okay. Is everybody caught up with me? I don't think I've skipped anything I needed to do today.
So we're done?
No. No, we got 2 more points to go. We're almost there. Yep, we did all that. Yeah, we're good. We're good.
Wait, can you go back to the one before?
Yep.
I can't do this anymore. So I'm about as unable to as her.
I don't have, no, it's in freeze. I don't have enough room to redraw that graph. Can I
Don't. Just put it on there.
Okay.
Yeah, mine was just looking cluttered, which is why I redrew it. So it was clear. All right, we got it? All right. The critical point. Now, the critical point, this is one of the weird points. Because you know how the triple point only had one definition?
Yeah.
The critical point has 2. They don't? I don't know. All right, the critical point, they subdivide into the critical temperature and the critical pressure. Okay? And what I was going to say is I don't know the reason why. Okay? I don't know why we have one definition for the critical point or the triple point and two definitions for the critical point. I just don't know. They didn't include me when they made this decision. All right? They should have, but they didn't. All right? So the critical temperature is the temperature above which a liquid can no longer exist.
Same thing for critical pressure.
No,
What?
it's not. All right, so the critical pressure is defined as the lowest pressure at which a liquid can exist at the critical temperature. They're sort of opposites of each other. So the critical temperature is the temperature above which the liquid can no longer exist. Can't have a liquid anymore at the critical temperature. And the critical pressure is the lowest pressure at which the liquid can still exist. Now, again, why they did it this way, I don't know.
Can you explain that more?
I'm going to show you how it exists on the graph, and it makes more sense if I use the graph. All right? Once I put it on the graph, it makes a little more sense. The definitions are just bizarre. Once I put it on the graph, it makes a lot more sense. Okay? So, how are we going to find this? Okay, so on the graph, first of all, it has to be on the liquid vapor line. Okay? Has to be on the liquid vapor line. It can't be any place else. And it's where it stops or goes straight up. Now, 9 times out of 10, it stops. Every now and then, you will see a graph where it goes straight up. I've not seen one of those very often, but every now and then, you'll see a graph that goes straight up. I'm betting whichever one you see on the exam, if you see it, it will just stop, which is what we usually see. Okay? But it has to be on the liquid vapor line, because what the critical point is you're a liquid and suddenly you can't be a liquid anymore. You can only be what state once you pass the critical point. You can only be a gas once you pass the critical point. Okay? You're a liquid all the way up to a critical point, and once you hit the critical point, you can only be a what after that point? You can only be a gas. Okay? So catch up with me and I'll label it on the graph. Everybody there? So if I go back to the graph, now we have to be on the liquid vapor line. Okay, so this is the liquid, that's the vapor, right? So this is where the line ends. So that right there would be the critical point. Okay, because that's where the line ends. So once I get to that point, everything to the right of that point is going to be a what? Everything to the right of that point will be a gas. Okay, you can't be a liquid beyond that point. That's what the critical point is.
Wait, talk about going up.
Up and to the right. Everything beyond it. Up and over.
So what is all that about pressure?
It's just talking about the lowest pressure, meaning everything beyond it down this way would still be a liquid. All right, last 2 points. Yep. They're almost the same.
You asked her if she was done, and she said no. Then
Oh, sorry. I thought everybody said yes. I didn't hear her.
Nobody else said.
Oh, I didn't hear her. I wouldn't have just gone on if I heard her.
yeah, sure.
I only do that 4th period. You sure? Okay. All right, so the last 2 points are the normal melting point and the normal boiling point, which is why I said they were the same 2 points. Okay?
How much space do I need to leave?
Not much. Now, we are not even really going to define them. Okay? Because we really already did this. Melting point changes from a what to a what? Okay, so solid to the liquid. And boiling point is what to what? Liquid to a gas. So you have to do these on the solid to the liquid line. So this has to be the liquid to the gas line. And what was the catch we just did when we did the equilibrium vapor pressure graph? See how I said normal melting point and freezing point and normal boiling point? That word normal makes all the difference. That's right. All right, you have to find at standard pressure.
Wait, so like so the other one's called critical point, that was like the final thing?
Yep.
What is that?
This is called normal melting point and boiling point. Normal freezing point. So anytime you use the word normal, normal means find at standard pressure. So we have to draw a line in at standard pressure to find these points. So we need to make up a pressure unit for huh? She said something on my desk. No, it's not for y'all either. So if we go back here, give me a pressure unit you want to use.
Atmosphere.
Okay. So if we put atmospheres right here as our unit, we're going to say ATMs. Number 1. Okay? We have to draw in a line. It's not going to be there for you most likely. So I'm going to draw in a dotted line. Okay? This right here will be the what? Okay, that's the normal line. But what am I intersecting? That's between the solid and the what? So that is my normal melting point and freezing point. All right. This intersection will be my what? Normal boiling point. Now, why will that be the melting and freezing point and that be the boiling point? What makes it different? That's going from a solid to a liquid, and that's going from a what to a what? Liquid to gas. The V is a gas.
Are we done now? Are you serious?
I have 7 minutes.
You said you would stop.
Phase diagram. I said I would not teach kinetics. I'm not breaking my word. Am I?
No.
Technically,
you're lying by omission, but you just told me you were going to do it. Which, so you're breaking it.
What you want to do for doing this?
Jeff, I can't.
You making a shame.
I think you should take.
That's true. You know, there are extra cops in the building there beside me to shank.
Miss Whitaker. Oh my God. The other minute, I was sleeping on a couch. I can break it if I need to.
Huh? She's gonna jab you with the fingernails? That's pretty personal. They always say me out with the nails. They got ready to get closer to, sailors. Rather be taken out by the candy cane. I'm going sailors.
I feel like you.
Now, y'all can do this in probably 2 minutes flat.
Okay.
It won't take you but a couple minutes.
That's really heavy.
Caroline's already down to like number 6. It's that fast.
Because
What did you say?
Caroline is
That's
Caroline.
nasty.
You still write your name on the paper.
She said G-A-Y. This graph looks because I lost my keys.
Oh,
Oh my gosh.
they're right there.
Honestly, I can have a heart attack now. Next down for a minute.
By all means, have a seat. You will not need to have, huh?
Upstairs 3 times. And I found them. They're right here.
I'm glad you are not going to freak out. I said, I'm so glad you're not going to freak out. I would be freaked out. Are mine over there? I don't know where mine are. Hopefully they're over there.
They're right there.
Okay, I normally have them in my pocket.
Thank you for that. I love the smell. I love green.
It's the same thing. I'm gonna put their book up when we're done.
You got them done?
Thank you.
No.
Tell you what, I will not even look over it.
Does that mean we have to do it every break?
No, just finish it now.
Wait, did I make it up that you weren't gonna get
So we're done?
You need to what?
Then you said you weren't getting homework on Christmas break.
I do not give homework over Christmas break.
That's what I thought. And
I am not doing any work over Christmas break.
Teachers are amazing.
I have uploaded my plans for Ms. Harvey. I have updated the website for whoever might check. I will make sure I have something to do for us on Wednesday when we return. Beyond that, I don't plan to give this place a great deal of thought between 3:40 this afternoon and around 7:40 on the 2nd. I hope y'all all have a very Merry Christmas, a restful break. Be safe. Do not do anything that's going to get you in trouble. Try not to push your parents off. Stay out of their hair. I hope you have a Merry Christmas. I hope it's one that you can stay out of their hair and make it stay out of your hair, maybe? Okay, maybe not. Opposite sides of the house, maybe?
We already are on opposite sides of the house.
Mine too. Dang, that was like, I don't mean to be rude, but. Hey, look,
I've
I'm
always
like,
said I should have left halfway through my computers so I could go check it.
No, I need a pair of apples.
You get
I know,
that.
I like this. I get that way all the time, but I'll put it down. Can't do either.
Good morning, students, staff. Just a reminder, there's no grab and go. Students should report to second period immediately, not the cafeteria. Have a great day.
I have no idea what was better than
I said I'm a starving child. Didn't have work.
I'm supposed to say, you're not starving, you got a sandwich. They're gonna say, you just ask Annette if she did something. She didn't even bring her papers with her today.
Small.
I know. I'm gonna be up there with Miss Baldwin with Cassie and throwing shade. Here, Chris. hand me Cassie. I'll take care of it. Almaj, don't fall down today.
Okay. Goodness. She doesn't know.
No, I don't. Be careful, this is my bus.
He was just one. Oh.